Ever glance up at the stars and, imagine something out there just suddenly lighting up, like a brand new beacon in the night?
Yeah, that unexpected flash.
Exactly. That's what our deep dive today is all about. We're getting into the really fascinating world of transient astronomical events.
And our guide for this is the Gaia satellite. It's pretty special.
Right. So what makes Gaia so good for this?
Well, what's really captivating about Gaia is its unique approach. See, unlike a lot of sky surveys that look at specific targets, Gaia just, well, it takes a big snapshot of everything bright enough that it sees.
No preset agenda.
Nope, no preset list of objects,
Yeah.
which makes it perfect, absolutely perfect for finding those unforeseen things, the transients.
Gotcha. So our exploration today, it's centered on Gaia's science alert system,
Mm,
like a cosmic breaking news feed. Yeah.
pretty much. Notification service for things that suddenly flare up or change in the sky.
Okay. So our mission for this deep dive is to understand why Gaia's knack for spotting these transients is such a big deal for astronomy and, look at some of the cool discoveries.
Exactly, what it's enabling.
So let's get down to it. What exactly are these transient sources?
Okay, so in simple terms, they're basically astronomical objects that change brightness significantly and pretty quickly.
Over a short period.
Right. And the key thing is unexpected. Because you can't predict them, they don't usually make it onto normal observing schedules.
And they're important because...
Because they often signal really dramatic stuff happening out there. Big astrophysical events, vital for discovery.
Okay, give us some examples. My mind jumps to, like, shooting stars, but I guess it's bigger than that.
Oh, much bigger. Supernovae are probably the most famous, right? These huge explosions when certain stars die.
Right, the big ones.
Yeah. And just for scale, there's a survey called ASSN, the All-Sky Automated Survey for Supernovae. It's designed to find them, and it finds hundreds each year.
Okay. But Gaia sees more than just supernovae.
Oh, yeah. Gaia's view is much broader. It can spot galactic novae stars in our galaxy suddenly brightening up. Cataclysmic variables.
What are those again?
They involve dramatic changes in binary star systems where one star is feeding off another, really energetic, plus powerful flares from stars, even comets brightening as they get near the sun.
And there's more, right? The source mentioned some really, weird stuff Gaia can see.
Indeed. Gravitational microlensing events, that's a fascinating one.
Explain that a bit.
Okay, imagine a star passes in front of another, more distant star. The gravity of the foreground star acts like a lens.
Bending the light.
Exactly. It bends and magnifies the light from the background star, making it look brighter for a while. It's super interesting because it gives us a totally different way to hunt for exoplanets.
Different from the usual transit methods.
Yeah, sensitive to different kinds of planets and systems. And then there are tidal disruption events, or TDEs.
Sounds dramatic.
They really are. That's when a star gets too close to a supermassive black hole and just gets ripped apart, causes a huge flare of light.
Wow, okay. So Gaia's watching for all these sudden brightenings. How does it actually do that while it's busy mapping, billions of stars?
Ah, that's the clever part. It's a mix of brilliant engineering and really sophisticated data processing. Gaia is constantly scanning the whole sky.
Continuously.
Continuously. And its instruments are incredibly precise, measuring the brightness of everything above a certain limit. Then there's a dedicated data processing system. It's run by Simon Hodgkin's team at Cambridge.
Right, the Institute of Astronomy there.
Yeah. They sift through this just massive amount of data, specifically looking for new things, sources that weren't there before, or big jumps in brightness for things it has seen before.
And this happens fast. It's not like waiting years for results.
No, remarkably fast. Typically just maybe 2 or 3 days after Gaia sees something interesting, an alert goes public.
That quick turnaround must be crucial.
Absolutely vital. It lets astronomers jump on these discoveries right away, follow them up with other telescopes.
And these alerts, they're not just a flag saying something happened here, are they? They contain actual data.
Oh, definitely. The public alert pages are a real goldmine. You get the brightness Gaia measured in its G-band filter.
Like looking through specific colored glasses for stars?
Sort of, yeah. Different filters tell you different things. It also includes any past measurements Gaia took of that spot. And crucially, light curves.
Plots of brightness over time.
Exactly. Shows you how it changed. And even low-resolution spectra.
Breaking down the light.
Right, like a rainbow, but much more detailed. It tells you about the object's temperature, what it's made of. Really useful stuff.
Which leads perfectly into the next bit, the wider community getting involved. It's not just Gaia working alone here.
Not at all. That ground-based follow-up is essential. There are actually specialized apps now.
Apps for astronomy alerts.
Yeah, they let professional astronomers, amateurs, even school groups with telescopes get these Gaia alerts and quickly point their own instruments at the new transient.
That's fantastic. So anyone can potentially contribute.
If they have the right equipment and know-how, yes. It's indispensable for getting more detailed observations, figuring out what these things actually are.
A real collaborative effort. And I noticed the naming convention sounds familiar.
It does, doesn't it? It follows the pattern used for supernovae. You know, SN, then the year.
Yeah?
Well, Gaia transients are Gaia, then the year, then letters. Like Gaia 14A, Gaia 14AB, and so on. Keeps things organized.
Makes sense. So Gaia's been doing this for a good few years now. What are some of the early results? Are we talking dozens? Hundreds?
Well, the very first one they reported, Gaia 14, that was back in August 2014, announced in September. It turned out to be a Type Ia supernova.
A standard candle one.
That's the type, yes. And Gaia caught it getting significantly brighter, went from magnitude 19.22 to 17.32.
That's quite a jump in brightness, isn't it?
It is noticeable. And fast forward to the end of 2020, after about 6 years, Gaia had issued nearly 15,000 alerts.
15,000, wow.
It's a huge number. Now, about 50 of those were really brighter than magnitude 12, but yeah, nearly 15,000 potential transient events.
That's just mind-boggling.
Yeah.
Have they figured out what all of them are?
Well, that's the exciting part. No, not yet. Our source says about 2/3, maybe 10,000 of them are still unclassified. Lots of mysteries still to solve.
But the ones they have classified, what's the breakdown like?
Of the roughly 5,000 classified, it's a real mix. Around 500 cataclysmic variables, about 100 active galactic nuclei, those bright galaxy send-ins.
AGN, right.
Right. Over 600 variable quasars, which are related to AGN. Then the big ones, 1,500 Type Ia supernovae.
The distance measuring ones.
Yep. And 500 Type II supernovae from massive stars collapsing. So a really diverse cosmic zoo.
With that many events, especially the supernovae, are we starting to see patterns that maybe, challenge how we thought stars evolve or galaxies behave?
That's exactly the kind of science these huge data sets enable. I mean, for the most part, the classifications fit our existing models, but the sheer number and finding things in unexpected places or with slightly weird behavior, that definitely pushes the boundaries and makes us refine the theories. There's always nuance.
You mentioned microlensing earlier. Has Gaia's alert system really boosted that field?
It certainly has. Nearly 50 microlensing events discovered just through the alerts, mostly in the plane of the Milky Way, where you'd expect them because there are more stars packed together.
Any standout examples?
Yeah, there was one called Gaia 17 Sayarella. It brightened by a whole 4.5 magnitudes. That's a huge increase.
Wow.
And while Gaia does other microlensing science too, these alert discoveries are fantastic data points for mapping mass in the galaxy and, like we said, potentially finding planets.
Okay, and what about the really violent stuff? The tidal disruption, stars getting eaten by black holes. Has Gaia seen any of that happen?
Well, it's a hot topic. Gaia has tagged 100 alerts as originating in active galactic nuclei.
Which is where the supermassive black holes live.
Exactly. But in the initial analysis from the Cambridge group, none were definitively called TDEs. However, other researchers, using slightly different methods on Gaia data, found nearly 500 other nuclear transients, things flaring up near galaxy centers.
And some overlap.
A few overlap, yeah. So the feeling is Gaia seeing them, or things very like them. It strongly suggests Gaia is going to be a major player in finding TDEs as the analysis gets refined. We're likely on the verge of detecting them routinely.
So far, it's all been about things getting brighter over days, weeks, maybe months. What about really fast changes, like blink and you miss it fast?
Yeah, good question. Amazingly, Gaia can probe that too, even though its view sweeps over a point in only about 45 seconds.
That seems incredibly short.
It is, but the way the detectors read out the data allows them to pull out variability information on much shorter timescales. Studies, like one by Weavers and colleagues, showed Gaia can spot brightness changes down to maybe 0.3 magnitudes.
That's not huge, but detectable.
Detectable, yeah. And on timescales from just 15 seconds up to several hours.
15 seconds. That's incredible. Have they found anything?
They have. They identified 4 candidate fast transients just in a small patch of sky. The initial guess is they're probably flares on different kinds of stars. But it opens up a whole new window on rapid cosmic events.
It really feels like Gaia is connecting dots across all sorts of astrophysics. Don't tell me it also links up with gravitational waves.
But it does, seriously. Gravitational wave astronomy, picked off big time with LEGO's first detection in 2016.
Detecting ripples in space-time itself. Amazing stuff.
Truly revolutionary. And while the waves themselves are invisible, the events that create them, like neutron stars merging, often produce light, too, an electromagnetic counterpart.
Like that famous neutron star merger, GW 170817.
Exactly. Seeing the light and the gravitational waves gave us so much more information. Finding those counterparts quickly is key.
So how does Gaia help there? Can it see the flash from a merger?
The potential is definitely there. Research, like by Custer Casca and her team, suggests that for a decent chunk of gravitational wave events, maybe 16 to 25%, the location could be scanned by Gaia within a few days.
Just by chance, as Gaia scans the sky.
Just by chance, given its all-sky coverage. And they've developed algorithms to specifically look for potential counterparts in the Gaia alert data. They reckon these algorithms might flag around 20 candidates per day when there's a gravitational wave trigger.
20 candidates a day? That's huge.
It's a lot to sift through, but the potential payoff is massive. This synergy, combining gravitational waves and Gaia's rapid alerts, it's a whole new era of multi-messenger astronomy, understanding the universe's most extreme events.
It's just staggering how this one mission, essentially just by mapping the sky over and over, touches everything from star death to black holes to space-time ripples.
It really is remarkable.
Now, we should probably reiterate, though, that these transient alerts, while amazing, are just one part of what Gaia does, right?
Oh, absolutely. Essential point. We focused on the alerts today, but Gaia's main job is still creating that incredibly precise 3D map of the galaxy. Plus, it provides unbelievable data on regular stellar variability, on asteroids and comets in our solar system, and it even finds exoplanets using the transit method.
It's the gift that keeps on giving for astronomers.
You could say that, yeah. A truly multifaceted mission.
Okay, so let's wrap this deep dive up. If you had to boil it down, what are the absolute key takeaways about Gaia's transient alerts?
I'd say. 1, Gaia's unique all-sky scan strategy is key. It finds the unexpected. 2, the speed getting alerts out fast is crucial for follow-up. 3, the sheer variety of things it's finding is incredible.
Supernovae, AGN, microlensing.
Right, and 4, the exciting links to other fields, especially gravitational waves. It's connecting different parts of astrophysics.
It really gives you that aha moment, doesn't it? Like, the universe isn't just static points of light. Gaia is showing us it's incredibly dynamic, constantly changing, sometimes violently, things we just couldn't see systematically before.
Exactly. It's revealing a universe that's much more active on short timescales than we perhaps appreciated. We knew these things happen, but Gaia is showing us the scale of it.
Mind-boggling is the word that keeps coming up. We really had no idea quite so much was going on up there, so often.
It shifts your perspective, definitely.
So if someone listening is really intrigued by this, wants to see more.
Well, the public Gaia alerts pages are the first stop. You can actually go online and browse the latest discoveries, see the light curves, the data.
Really dig in.
Yeah, and for people who are into amateur astronomy, maybe even have a decent telescope, looking into the follow-up networks could be rewarding. You could potentially contribute to real science.
Amazing. Okay, final thought then. As we look up at that night sky, which maybe seems a bit less static now, what should we be pondering?
Maybe this. With Gaia finding thousands upon thousands of these transient events, this constant stream of cosmic surprises, what completely new things are we about to stumble upon? What fundamental processes are waiting just under the surface? Things we haven't even thought of yet.
Because Gaia is giving us this unprecedented, wide-angle, high-cadence view.
Exactly. It's a universe in flux, and Gaia is giving us a front row seat. Who knows what the next act will reveal?